We live in amazing times. We are here at the banking conference talking about banking transformation, and we have a lot of digital topics on the agenda. And I think that's really interesting in relation to banking. And I'm adding something to this as well, which is quantum computing. And I think AI and quantum computing will have a big impact of the bank of tomorrow. I have only 25 minutes. I think you have a 5-year study or so for quantum computing normally, and then you don't just understand parts of it. So let's see what this is and what it can be for future banking. If you look at banks of the future, and I've seen this idea for the digital business model, a new digital business model for banks, I always call this a smart bank, a digital smart bank. So instead of talking about AI and all the components of AI, I just see it as a smart bank. So we have a lot of processes that go automatically. Your customer interaction is smart, your auditing is smart, all your processes are smart, and also the interaction with your customers is smart. If we look at the old days, we didn't even have digital. So the roles of banks was different, the roles of insurance companies were different, and also the way we dealt with information and with knowledge and so on was really different. And this all changed when we came into the first machine age. And then we got knowledge, paper, and so on. Shortly after that, and that's I think where we are now, some call it the second machine age, but I think we should call this the smart machine age. Because what we see now is that technology is becoming so mature that we see smart machines, smart robots, smart autonomous vehicles, and we see intelligence and we see digital everywhere. If you look at the topic of AI, AI is not new. I think it's an old topic. It's around for 30 years or so. Most of you will have heard this discussion a couple of years ago, and now it's coming up again. So the question is, why is it really mature now? Somebody who's really famous for his AI paper is Alan Turing. Anyone knows Alan Turing? Yeah. So he also created a test to test the maturity of AI. Does somebody know what kind of test that was? Conversation. Yeah, conversation. So what did he do? So the other guy won't know that he's talking to him. Exactly. So he invented a test, and the test is you are chatting to somebody, and you get responses, and based on the responses, you give like a jury number or something, and then you have to decide, is this an AI or is it a real person? They didn't have voice for this, they only did it through chat, otherwise you would be able to recognize the voice. That was a bit of the idea. So I thought this is an amazing crowd, banking crowd, so I thought let's do a live Turing test now with all of you. So I'm going to, you don't have to chat, I will introduce you to Samantha West. And Samantha West is working for Medicare. And she's calling people to sell Medicare products. So I just would like you to listen to this, and at the end you have to vote by hand raising to tell me if it's is she either an AI or is she real? Yeah, it takes about 2 minutes, so listen carefully.
Hello, how are you today?
Okay, how are you?
Good. Well, I'm calling about an online request you once made about health insurance coverage. We work with all major companies and compare all the rates for you. I can get you a quote in about 5 minutes, okay?
Are you a robot?
I am a real person. Can you hear me okay?
I can hear you just fine, but you sound like a robot.
I understand. Can we continue?
Sure.
Are you currently on Medicare?
No. Why are the questions so personal?
We received your online application for health insurance, and if you're still looking for affordable health insurance with excellent coverage, we can give you a free quote.
Why should I give my information to you?
I understand, but we do work with all carriers, and I can get you a low rate. Getting a quote will only take a minute, okay?
You really do sound like a robot.
I am a real person. Maybe we have a bad connection. I'm sorry about that.
Are you sure?
Yes. Sure.
I'm gonna hang up now.
Okay.
She's a bit
Have a
disappointed
nice day.
at the end. Interesting conversation. It takes a bit long. Thanks for listening to it. Okay, let's do some voting here. So who thinks she is a robot? Okay, who thinks she's real? Okay, who thinks this story is totally different? Yeah, so what is the story here? He's the robot. I've heard many varieties of this one. I heard somebody say before, I think both are robots, but you can look this up on Google. It's an interesting thing, and they try to figure out what was really the case, because this really happened. So they recorded these messages, and they really tried to figure out what was really going on. And it looks like it's working like this. It looks like the guy on the phone is called by something, and then his voice is translated into text. The text is translated into another language, and that has been given to people in a call center that don't understand the language. Yeah? So they just see a response, and then they have this soundboard, and they press buttons. That becomes text, it gets translated to something else, and then text is spoken to the person on the other side. If you see all this, then the question is this real or is this not real? And I think that's the element when we talk about AI. What is AI? If we really look at AI, a lot of people think of it as a big box, or a big black box with a lot of knowledge in it. The way we look at it is we just see it as a bunch of components. So we see components for image recognition. We see components for speech to text. We see components for translating language to another language. Yeah, responses, Q&A kind of things. So all these elements of AI are just components. And if you look at AI, of course we all know we are not there yet. So all these components will be developed over the coming years. But some of these components are really mature right now. For example, image recognition, speech, text analysis, those kind of components are already pretty mature. And that means you can take out these components and start using them for all your processes and things you do on an everyday basis. So why is AI becoming strong now? I think three components are coming together. First one is digital data. So we have a lot of data and it's all digital. And that's what you need to train your artificial intelligence components. The other thing is AI is becoming more mature, these components. And the third one is we have a lot of computer power. If you take this smartness and you put this in a machine or in a car, then you get this autonomous vehicle or an information-based robot or a machine for do actions like you have in the factory. Yeah? So this image recognition and so on, these are the components you put in these machines. This is an example of a smart city. And what you see here is digital data. You see cars driving around, you see people moving, and you see events happening. And also you see an overlay of the weather, the city buses, and so on. And now you see popping up intelligence that analyzes this data in real time and gives suggestions. For example, add an extra train, which is what you see here on the top right. But you also see security and marketing kind of recommendations. So based on live data in the smart city concept. If you can do this for a smart city, then you can also do this for your organization. All your transactions and flow of interactions, all these events going on, you can monitor these, look at them, and do analysis on them. And what you can already do with artificial intelligence today is you can predict demand on this. You can analyze performance problems. So where's the real performance problem in this city scenario? Maybe there are some specific patterns going on. Yeah? Maybe it's very busy on one specific time of the day. You can detect incidents or opportunities, but you can also find people or content in all of this. And that means you can do things like looking for people, detecting specific suspicious people, like it says here, or optimization of patrols walking around, or detecting objects, unattended objects in all of this. But you can also do marketing suggestions or detect illegal parking. Yeah. Just some examples of a city which can also be used in your internal organization as well. So how does that work? You see a car driving here, and you see it passes by other objects, and it can just recognize what the object is. Is the person a motorcycle, somebody crossing the street or not? So this is one of the components that they're using now for cars to detect if somebody crosses the street or not. But you can also use your normal standard cameras, add intelligence to it, and then make it an AI kind of camera. So you can detect which parking places are free and which ones are not. And you can use that data and do analysis over time to show what's available and what's not. You can even create an app for everyone that's visiting to show which places are free, because you are adding AI intelligence to your standard cameras, just as an example. But you can imagine that you also have the scanner in your own process, that you can also detect these kind of things and act upon them. If you look at the AI market, I think there's some ways of looking at this. I just thought let's give you a bit of an overview of the platforms available already. So these are the top 10s that you already see for deep learning platforms that you can start using right away. Another way of looking at it is at the AI patents. I think for 30 years we have created a lot of AI patents, and a lot of technology companies have built a lot of AI patents on specific topics around AI. There's only one non-technology company in there. Did you spot it? The US Army, a lot of AI patents as well. And what we also see now is we even see optimized hardware. So we see specific designed hardware specifically for artificial intelligence. We see it, for example, from Google. They have their new Google TPU. And we also from Fujitsu have our own Dealu, which is optimized for artificial intelligence as well. So if it's becoming more mature, then the question is, what are we currently already doing? And what I did is I looked at the top 10 banks of the world. You see a list of them here. And I tried to figure out, okay, what kind of use cases are they doing currently? So I looked at all the press releases, and I did some analysis on this. Well, this is the list of the top 10 banks. And I came to the conclusion of the following list. I added also the insurers, by the way. So what you see here is these are the use cases banks, the top 10 banks of the world, are currently working on. That doesn't mean it's all a success right now, but that means we see opportunities on these topics to really start using AI. So for example, the anti-money laundering topic, which is a really real concrete topic for now. A lot of banks have issues on this. Well, a lot of banks are also trying to use AI to do these kind of things and see how far they can get with this. But also automated credit decisions, but also the virtual customer interaction is also a specific one that many banks are testing right now. If we look at the insurers, we see something similar, like intelligent authentication. It just drops a bit off because of the conversion here, I think. But also self-service chatbots and also the virtual customer interactions, but also chatbots for claims. And so this thing you've just heard, the sound, the woman calling, we have these kind of things in a virtual agent kind of setup. And a lot of banks are doing experiments on this. And if you really open up these use cases, you will see at the end they always have the same components. So also you see here a chatbot that works through a mobile. You see on the left there is a customer that talks to a mobile phone. That is translated into text. That goes to an AI chatbot and goes back to speech. And that one is communicated to the person on the other line. Yeah? So at the end, you always build up your artificial intelligence with these kind of components. Another element of why AI is becoming so strong is this new concept of quantum computing. And I have 5 minutes, so I think that's an interesting challenge for here. So let's do quantum computing in 5 minutes. It's, what is it? Almost 5 o'clock in Portugal. Sounds good. Okay, if we talk about computer power, we see a combination of edge, quantum computing, and cloud. Cloud is already pretty known. A lot of companies are using cloud. Edge is pretty new, which means you can use all these devices connected to the internet also as computer power. But now we also have this new concept of quantum computing, where we are working on for many years already. Good to know, if you look at the old supercomputers, at the old days, they are now slower than a smartphone in your pocket, just so you know. Yeah, so the top 10 list you have seen always, and the big computers running and so on, they are slower than the iPhone in your pocket right now, just so you know. The other thing is, if you look at quantum computing, 2018 for quantum computing is like 1968 for traditional systems. Yeah? So at that time, we didn't really know what to do with it yet. It was really new. We didn't know how it would grow and so on. We didn't really know the impact and what it would be over time, yeah, because it was all pretty new. All these systems were really, really big, yeah, and so we really had to figure out to make them cheap and so on. We are at the same status now for quantum computing. Yeah? So this is still pretty new, and we really have to figure out where it can be really useful for organizations, but also where the real differentiator is. First question, of course, is why do we even need something like this? Well, we have still problems that we can't solve. Just an easy example, if you put milk in your coffee and you're stirring it, there's no way of calculating what happens when you put the milk in your coffee. Yeah? Just an example. The other one is if you have 30 locations and you have ATMs there, and you want to optimize the traveling that you need to do to fill those ATMs, and you want to verify the process, that's not possible by a normal kind of computer. Yeah? It's possible, but then you have to take shortcuts. A lot of things are based on mathematical problems, like the encryption. Everyone here uses encryptions for your websites. If we get quantum computing in, that means we have a different way of dealing with these mathematical problems, and maybe you can even break them. And we expect that quantum computing in the coming maybe 10 years will be able to break the current encryption standards that we have right now. Yeah? And we only see one way to solve this. Anyone a suggestion? Suggestion is use quantum computing for encryption. Yeah? Then maybe that will be the answer, but we don't know yet. If you look at quantum computing, it's not here yet. So we expect it to be in 2025, that it will be really mature so you can start using it. But there's already things available, what we call digital annealer, which are processors based on the concepts of quantum computing. And these are already available, so you can already start with some of the concepts around quantum computing to see how far you can get with this. So, what is quantum physics? Quantum physics, well, it says 5 minutes in 2 minutes. Okay. First, if you know something about IT, you know it's always about zeros and ones. Yeah? Computers only calculate with zeros and ones. Well, if you look at quantum computers, they have qubits. And qubits can have the value of 0 and 1 and every other value. It's a bit of a difficult concept, but if you read out the value, it will always be 0 or 1. So it can be every kind of value, but if you read it out, it's always 0 or 1. So you are calculating with probabilities. Very difficult concept, but you use probabilities to really to figure out what the position was and what the number was of the calculation. But just to mention here, see what we can already do with zeros and ones and how it grows exponentially in the computer power. Imagine what you could do if you have, well, multiple values, and it grows exponentially. Yeah? The calculating power will be enormous. The second concept, this is also based on physics, is this idea of what they call quantum entanglement, which means if you have a qubit, like I just said, the 0, 1, or any other value, it can interact with another qubit. And if one changes, the other one changes as well. So they have like a reaction with each other. And they can be a distance far away from each other. Yeah? Very complex concept. But it's interesting because in the old days, zeros and ones don't communicate with each other, but these zeros and ones can communicate with each other. And the third one is quantum tunneling. If you have a qubit and it moves, it can move through everything. It doesn't stop by a barrier. So, for example, this example of a tennis court. On the left side, you see a qubit. If this qubit moves from side 1 to side 2, it can just move through the tennis net. Yeah. This is a very short explanation of quantum computing, of course, in 2 minutes. Yeah? And it just gives you a bit of an idea of the elements of quantum physics and what's behind that. But of course, the main question is, what can all this power do and what can we do with this? And what we expect is that it can solve problems exponentially and in parallel. So instead of the old processes that we had, we can do it in parallel, which means we can solve problems a totally different way than we did in the past. But then the question is, what problems are exponentially complex? Well, for example, this one, optimizing the ideal route of traveling, the traveling salesman problem. Yeah? So you want to visit 50 cities, the traffic changes, what is the optimized route? And for example, there's a congestion somewhere in there, what is then the best route? Normally, if you would calculate this, done by the most powerful supercomputer right now, it will take 13.8 billion years. We can't even understand this because you think, yeah, but we can calculate everything. But if you do this with a digital annealer kind of concept, it takes you 1 second. So what are the use cases? The use cases we see right now, and we are doing a lot of experiments with banks together, to trying to figure out what are the real profits, where can we really find the value of quantum computing. And we see it in portfolio optimization. We see them in optimized ATM cache management. It's like a supercharged AI. That's where we see it as well. Non-performing loans, optimal trading, credit scoring, customer segmentation, and also classification of credit scoring as well. So these are just the new cases that we are currently are developing together with banks and insurance companies to figure out where's the real value of all of this, because we really have to figure this out in the coming years. So for now, I would say let's co-create on this and see how we can get together and see how we can really make this work for the future and define the future bank. Thank you for listening.